Hi, welcome to this week's video. I spent most of the last week updating a financial application, primarily the workflows and where data is located and how the data is processed to make it a bit cleaner and more applicable to a larger group of people. So I haven't had time to focus on any of the Alteryx blogs that have been asking some questions to come up with some new source for today's video. I did, however, receive a note from Google saying that sometimes it's nice just to do a greatest hits kind of video. And while that doesn't really apply to doing data manipulation, it did remind me because it's one of the problems I had to correct within the application, and that is how to do inserts and updates into a table from a transaction file. Now there is a larger video. If you look down through this list of videos that I have, I've discussed this topic in many different videos and workflows, some in more detail than others. But what I was wanting to look at today is simply to say, well, what happens if I have a fairly large table? Is this still going to work? And so we're going to simply look at how you would do an upsert within Alteryx and use Alteryx Database Tables as opposed to a RDBMS table, just in case you're concerned about performance, which is sort of what I was concerned about while I was working on this. So let's take a look at my table that I have up here in my SQL, and I have this puppy training large fact table that I've used in a couple of other workflows, and it has upwards of 78,000 records in it. And for this purposes of this little exercise, I went ahead and added a primary key as well. Did a little bit of data cleanup along the way because this was really just a performance testing table. And the concern is, and again, this isn't really that large of a table, 78,000 records. It's actually a reasonable size, but it just gives you an idea as to how Alteryx might be able to handle a larger set of data. Because you have to remember that Alteryx, because of the way it deals with one record at a time, is extremely extensible and scalable. So if you just take a very basic workflow, it will and look at how it works. If you add additional features into it, you don't really slow it down a whole lot. If you add more data onto it, yes, it will be slower, but it will not be progressively slower. It will simply be linearly slower, if not less than linearly. So I decided I just wanted to see if I move this large table down to an Alteryx database table in its internal format and did all the work on my local machine within Alteryx and not using the RDBMS for any kind of storage, what will that do to my overall process? So that's what I did. And we'll go ahead and pop up the two Alteryx workflows because, again, not spend a lot of time in looking to build this through, but simply just to do some highlights. So if you look at the very simple process of doing your update, and that is if you're on an RDBMS, so here I actually have my, oops, it's right. I actually don't have to have it for input. So here's my transactions that are coming in. There is 10 transactions, 10 fields, 100 transactions. 90 of them are updates, and 10 of them are inserts. I went ahead and used my date time now to get a date time stamp into this, or a batch timestamp into this, and then all I'm going to do here for my RDBMS MySQL is just do update insert if new, and that way Alteryx will actually look at the primary key fields which we have sitting up here in order to do the update or insert for me, and doing its internal process determine which to do when. So we take a look at basically putting 100, which would be a day's worth of transactions, going into the historical transactions, which is upwards of 78,000, 79,000 records. And what does this mean? Well, it simply takes and looks at the execution. You see that it did 100 records in. It actually says inserted because it doesn't look at whether it's updated or not. So 100 records went up into it, and I verified the data going in there that we did indeed just simply add the 10 additional records. And you can see that overall it took it 13.1 seconds to go ahead and move those records, do the testing and comparison, and insert them into the RDBMS. Pretty quick, pretty simple. So let's look at what we would do if this data is in Alteryx database. tables rather than the RDBMS table. So here I have, again, I have my 100 records that are the transactions, 90 which are new, or updates, and 10 which are new. I add my date time to it as a timestamp, and then I bring in my 78,000 records that are in a YXDB file, which is an internal database file. And so now, if you remember going back, look at some of the videos, we'll talk more about this in the videos, rather than just really looking at an overview of this and looking at how performant it is. We will then join these two tables together using the three primary key fields. And what we get out of that join is, since we have the new data on the top or left and the old data or existing data on the bottom or right, the left becomes the 10 records that need to be inserted. These are not updated, these are brand new records. These 10 records will be inserted in. On the right, we have the 78,000 records that are not touched at all. And then we have the 90 records that are the updates, which go out through the join. Being a little creative with the way I do it, a quick little tip is that I used my new records on the left and my existing records on the right, so that I did not have to change the names associated with the join. I just could turn off all of the right records because I wanted to keep all of the left side of the records. Otherwise, I would have to do a rename of all these, which can be a little bit tedious. So again, using the widgets in the right order, knowing what they're going to look like, this gives me the three data sets that are all identical in the easiest way possible. Once I have those three sets of records, I union them back together again. So now I have a full set, new records, updated records, and non-changed records. And then I simply put them back into an Alteryx DB file. Pretty straightforward. It happens to be, again, 78,000 records. So I was wondering how long it might take to do this. And it turns out it took it less than a second. In fact, it took it 0.2 of a second to run through this process. So it read my records, read my change record, 100 of changed records. It read my 78,000 plus records that existed. It did the join between them. It unioned everything back together again, and then wrote it out to my YXDB file, and the whole thing took 0.2 of a second. And that was extremely fast, much faster than I expected it to be, and it made me happy, the fact that I was planning to do some conversions to bring a lot of data locally to support the application as opposed to keeping them in a database, which limited their access and usability. Bottom line is that you can continue to get performant results out of your workflows, even if you don't have an RDBMS. You just have to understand how to translate some of the actions that the RDBMS would do for you. And in this case, it is how to do an upsert, which is through a join instead. So again, that's a very quick look through all this. Please subscribe if you like this and want to know other things that are coming. Like this, drop a comment if you enjoy it, but this was just a tertiary overview of this whole process. Please check more of my videos that are on this list so that you can see some more details about how all this works and the different ways to handle the updates of your database tables, and then obviously your local tables as well. I'm going to be offline for a few days, and so I just wanted to get this out quickly to you. So y'all have a great week, and I will see you later.